Hi, this is Dr. R. Vijay Chandra, working as a professor in Nanda College of Technology, Erode. So, in this video, let's see correlation. So, correlation is the degree of the linear relationship between two variables. Correlation analysis, it's a statistical tool that measures the closeness or strength of the relationship between the variables. In correlation, two variables are interdependent or covary, and we cannot make distinction between the independent and dependent variables. For example, birth weight and maternal height, drug intake, and number of days taken to the cure, etc. Correlation analysis is not only establishing the relationship but also quantify it. Correlation is unable to indicate the cause and effect relationship between two variables. Then there are three types of correlations: positive and negative correlation, simple partial multiple correlation, linear and non-linear correlation. So let's see positive correlation. This correlation is also called direct correlation. An increase or decrease in the value of one variable is associated with the increase or decrease in the value of another variable. In this, both variables move in the same direction. For example, the number of tillers and plant yield in wheat, plant yield and number of parts, number of days and height of the plant, etc. we can say. Negative correlation, which means increase in one variable causes the proportionate decrease in the other variable. That means if one variable increases means another variable decreases. Here the two variables move in opposite direction. For example, supply and price of commodity. If the supply of the commodity is more, price fall, of course. And if there is scarcity of the commodity, then the price goes up. Here there is negative relationship between supply and price. Then let's see correlation coefficient. Scattered diagram and graphic method only gives a rough idea about the relationship between two variables but does not give numerical measure of correlation. The degree of relationship can be established by calculating Cole-Pearson's coefficient, which is denoted by R. So let's see the definition of coefficient of correlation. The coefficient of correlation, which is denoted by R, it can be defined as a measure of strength of the linear relationship between the two variables x and y. Now, we see the formula for correlation coefficient. It is defined as small r is equal to summation x minus x bar. Here x bar is the mean into y minus y bar divided by square root of summation x minus x bar into y minus y bar, where x is the independent variable and y is the dependent variable. X minus x bar is the deviation from AM. AM means arithmetic mean. Similarly, y minus y bar is the deviation from the mean. If this r is greater than 0, the correlation is positive. If it is negative means the correlation is negative. If r equal to 0 means we can say that variables are not related. It is not correlated. Let's see the characteristics of correlation coefficient. The value of R ranges between minus 1 and plus 1. If there is no relationship at all between the two variables, then the value is 0. On the other hand, if the relationship is perfect, which means that all the points on the scatter diagram fall on the straight line, the value of R is positive plus 1 or minus 1, depending on the direction of line. Other values of R show an intermediate degree of relationship between the two variables. That is, the most important thing is R takes the value either plus 1 or minus 1 or 0. If it takes plus 1 means it is a positive correlation. If it takes minus 1 means it is the negative correlation. If it is equal to 0 means there are those variables are not related, not correlated. That's all. the same thing. This shows the same thing, a positive and negative correlation. Merits of correlation coefficient. It is the numerical measure of correlation. And second one is it determines the single value which summarizes extent of linear relationship. It also indicates the type of correlation. It depends on all the observations so give true picture. Now let's see the correlation applications where it is applied. In agriculture, genetics, physiology, medicine, etc. Correlation is used as a tool of the analysis. In agriculture, correlation is widely used as a tool of analysis in agricultural sciences. Example, to estimate the role of various variables such as fertilizers, irrigation, fertility of soil, etc. on crop yield. In physiology, using regression and correlation analysis relationship between germination time, temperature of soil, alkalinity of river water, and growth of fungi, etc. It can be measured, estimated. So, in continuation with that, correlation analysis finds a lot of application in genetics. For instance, when R equal to 0, that is correlation coefficient is equal to 0, then it indicates the concerned genes are located at distance on same chromosomes. When R equal to 1, it indicates that genes are linked. This correlation analysis is very important in gene mapping. Okay. So hope it will be useful to you. Thank you. Thanks for watching.